Dragon is in countdown. Falcon 9 is in startup. Dragon, SpaceX, go for launch.
We're about 24 minutes and counting from liftoff of this Falcon 9 rocket for NASA's and SpaceX's 25th commercial resupply services mission. The Dragon spacecraft you see there will fly more than 5,800 pounds of science, supplies, and food for the astronauts aboard the International Space Station. Good evening, and thank you for joining me for live launch coverage of CRS-25. I'm Megan Cruz. You just saw Falcon 9 and Dragon on Launch Complex 39A here right behind me at Kennedy Space Center. Fueling began about 10 minutes ago, and we have an instantaneous opportunity to launch at 8:44 p.m. Eastern Time. These resupply missions are important so NASA and its international partners can continue to conduct microgravity research aboard the space station. Over the last 21 years, thousands of experiments have led to scientific advancements right here on Earth. Today, more than 24 experiments, including some that will study Earth's climate, are packed away in Dragon awaiting launch. Let's go now to SpaceX headquarters in Hawthorne, California, where we have Shiva Bharadwaj to tell us more about this mission, which Shiva, NASA and SpaceX were initially targeting last month for launch.
Thanks, Megan. It's great to be covering today's mission in partnership with NASA. And like you just said, we spent the last few weeks working through an issue on Dragon after teams discovered a small vapor leak. Since then, we've completed thorough inspections and replaced the components that could have been degraded by exposure to this vapor. And we've been working hand in hand with NASA throughout the process. And now we're ready to launch. This year also is the 10-year anniversary of Dragon becoming the first private spacecraft in history to visit the International Space Station, deliver cargo, and then return to Earth. 5 years ago was our first reflight of a Dragon on the CRS-11 mission, and since then we've made 31 flights to the space station with 14 reflights of Dragon. Today's mission adds to that tally and will mark SpaceX's 30th launch of 2022. It'll also mark our third Dragon flight this year, following the crewed launches of Axiom 1 and Crew 4 back in April. Now on screen is our Falcon 9 rocket and the Dragon spacecraft sitting at the very top. The capsule flying today is our first third flight of a new cargo Dragon, which previously supported the CRS-21 and 23 missions last year. Now, this version of Dragon is certified for up to 5 flights, and it'll be joining the Crew 4 spacecraft, which is currently docked at the station. Moving down is our Falcon 9, our reusable 2-stage rocket. It's actually 2 rockets in one. That lower part is called the first stage, the upper the second stage. Today's Falcon 9 will be flying for its 5th time, and as that name suggests, Falcon 9 has 9 Merlin 1D engines at the bottom of the first stage. They are what accelerate the vehicle through the Earth's atmosphere and to those various orbits in space, and we've got a great photo of those 9 engines before we roll them out to the pad on Tuesday morning. We're going to be attempting to recover this first stage on our drone ship named A Shortfall of Gravitas, which is off the coast of Florida out in the Atlantic Ocean. Now, above the black inner stage of our first stage is the second stage. The stages separate about 2.5 minutes into the flight, and then that second stage ignites its Merlin vacuum engine to carry Dragon to the targeted orbit. A little later on in the show, we're going to talk about how Dragon navigates to the station after we separate from Falcon. But for now, I'm going to turn it back over to you, Megan.
Sounds good, Shiva. Thank you. In addition to SpaceX, NASA teams both here in Florida and Houston are monitoring today's launch. You'll hear from Sandra Jones, who you see in there inside with Mission Control in Houston. But first, let's check in with Daryl Nail, who's monitoring the launch team here at Kennedy. Daryl.
Yeah, thanks, Megan. Everything looking good so far here from Hangar AE at the Space Force side of things. You can see behind me the data and telemetry flow through this building. We're happy to be here and appreciate them having us here. Out to the rocket we go, and you can see it is twilight here on the eastern coast of Florida at historic Launch Complex 39A. You can see the rocket is being tanked. The launch director gave the go around 8:06 p.m. for tanking to begin, and that RP-1 is now flowing into the first stage and the second stage, along with the liquid oxygen, which you can see along the rocket the center part of the first stage. You can kind of see the fill line where it's at the part that's chilling. We do have a small issue with the weather. We're currently 70% go, but the launch weather officer for the Space Force briefed SpaceX's launch team about this right here. And you can see this is some weather imagery that we have here. Storms are bubbling up really heavy along the center part of the state. You can see it's all pushing to the west, which is good because there's some easterly flow. However, the Space Force is able to monitor what's called an outflow boundary that is coming back to the east and is scheduled to be here at the launch site right around T0. So, as you can see from the graphic on your screen, they're holding the percentage go at 70%. Normally this time it would be a little bit higher, but they're going to hold it at 70%. The concerns are cumulus cloud rule and flight through precipitation. Winds are 15 to 20 miles per hour. Other than that, we're looking good to go. And let's head out to JSC in Houston and join Sandra for more.
Good evening. I'm NASA's Sandra Jones here inside the International Space Station Flight Control Room at the Johnson Space Center in Houston, Texas. Mission Control Houston is the nerve center for space station operations, and our flight control team is on console and ready to support today's cargo launch. Leading the team in Mission Control during today's launch is NASA Flight Director Scott Stover. You see him there on your screen right there. And when Dragon arrives to the International Space Station on Saturday, it will dock to the station's forward port of the Harmony module. NASA astronauts Bob Hines and Jessica Watkins will be on tap to monitor that approach. Dragon is slated to spend about 1 month attached to the International Space Station before it returns to Earth with research and return cargo and splashes down off the coast of Florida. For now, everything continuing to look good on the station side for today's launch, so back over to you, Megan.
Thinking about Sandra, and before that, Daryl. We are now about 17 minutes and counting from liftoff of CRS-25. Let's check out some of the science flying on this mission. A lot of impactful research going up with today's launch, and let's take a closer look at some of those that you saw in that video, starting first with EMIT, which stands for Earth Surface Mineral Dust Source Investigation. Joining me now is EMIT's principal investigator, Rob Green, and we also have NASA's Senior Climate Advisor, Dr. Kate Calvin. Great to have you here.
Wonderful to be here.
Perfect. So let's take a look at some video of EMIT, Rob. So EMIT is going to be attached to the outside of the space station, and it's going to study mineral dust. But what is mineral dust?
So mineral dust are the tiny particles of rocks in the dry land regions of our planet that under conditions of high winds are launched into the atmosphere. In the atmosphere, because they can be different compositions, they can heat or cool our planet, play a role in cloud formation, and many other impacts. Right now we know about mineral dust by about 5,000 different measurements that have been analyzed around the Earth. When EMIT is done, we will have 1 billion direct observations of the minerals in these dry land regions to advance the science of how mineral dust can heat or cool our planet.
And I think it's important to understand for people that, you know, we're not just focused on these arid regions. When you have dust storms, you can see a dust storm in Africa end up affecting us in Texas, per se. So why is it important to study these dust storms, and in particular to understand how they might heat or cool the Earth?
Well, as you point out, it's a global phenomenon on every continent except perhaps Antarctica, and that dust can travel thousands of miles from Africa to Florida to Texas, and it has impacts throughout the Earth system there. And then heating or cooling, when you have a global phenomenon, you've got to take it into account. Are those dust particles absorbing energy, heating our planet, or are they scattering light back into space and cooling our planet? So we need this information so the Earth system models become more accurate, so we understand what's happening now and in the future. And those are the two primary objectives of EMIT.
Yeah. So, Kate, it sounds like EMIT is going to be a real tool for us when we're studying climate change and just the Earth's climate. And it's no surprise that EMIT is one of a fleet of Earth-observing spacecraft.
Yeah, one of NASA's most important missions is our home planet. We have more than 24 satellites and instruments in orbit, including several on the International Space Station, that observe the Earth. So we can see things like carbon dioxide, vegetation, changes in the mass of ice sheets, and much more. And once EMIT is put onto the International Space Station, it'll join that fleet.
Wow. And I do know that it's not just what we have orbiting the Earth. There's also a lot of research being done on the ground. So when you consider this whole portfolio of climate research that we're doing, how will this help us address climate change?
Well, the more we know about the planet, the more we can use that to provide the local decision makers, stakeholders, and the public about what's happening on Earth.
Awesome. Guys, thank you so much. I appreciate your time.
Thank you.
And EMIT isn't the only experiment inside Dragon that will study Earth's climate. Students from MIT built what you're about to see on the screen here. This is called Beaver Cube, and it's named after the school's mascot, Tim the Beaver. It's a small satellite about the size of a shoebox, and once deployed, it will measure cloud properties, ocean surface temperatures, and ocean color to analyze Earth's climate and weather systems. T-minus about 11 minutes and counting from liftoff of NASA's and SpaceX's 25th commercial resupply services mission to the International Space Station. Let's bring back Shiva now to tell us more about Dragon.
Thanks, Megan. Now, Dragon is capable of transporting people as well as environmentally sensitive cargo to and from Earth orbit, like we are on today's mission. Starting from the top of the nose cone to the bottom of the trunk, it stands about 27 feet tall and is made up of two main sections. The pressurized capsule and the trunk, which is used for unpressurized cargo and supports the spacecraft on ascent and during on-orbit operations. Now, after separating from Falcon 9, Dragon will autonomously make its way to the International Space Station using its navigation sensors and its engines. The capsule has 16 Draco engines, which are used to get the spacecraft from one place to the next. Now, we've got 12 of those service section Dracos near the bottom of the capsule and 4 near the top of the forward bulkhead underneath the nose cone. Those forward bulkhead Dracos are primarily used for high thrust maneuvers like the orbit changes that we'll need to get to station and eventually in about a month to get back home to Earth. Each of those thrusters are capable of generating about 90 pounds of force in the vacuum of space. Now, the service section Dracos are used primarily for pointing and for operations in proximity to the space station. You can actually see them firing here in these clips taken from the International Space Station on various different Dragon missions as they were approaching the orbiting laboratory. And just like those Merlin engines on Falcon, we also reuse the Dragon thrusters, the Draco thrusters, once that spacecraft returns to Earth. Dragon and Falcon continue to remain in good health, and we're ready to support the on-time liftoff around 8:44 p.m. With that, back to you, Megan.
Perfect news, Shiva. That's what we like to hear. And two people very excited about today's launch are right here next to me. We have Claire Green and Benjamin Whitfield, both of Arkansas State University. They actually have an experiment on board and are about to tell us about it. Great to have you here.
Nice to be here.
All right. You're so excited. I love it. So let's take a look at the screen. We have some pictures of when the team was here earlier a couple of weeks ago, and you guys were prepping your experiment. What are you guys studying?
So we are studying waxworm larvae and their unique ability to break down thin plastics, thin plastic bags, into a non-pollutive byproduct. And we're very curious to see if they could still do this process in microgravity or aboard the space station.
Yeah, so we know that this happens on Earth. Why do you want to see if this happens in microgravity?
Well, the application of breaking down plastics is beneficial anywhere. It's a problem that we're learning how to deal with. So if we can learn how to deal with it on Earth and in the space station, then we can extrapolate that to other environments.
Why are you guys interested to see how this will react in space? Is it because we as an organization, NASA, we are thinking about going farther than we've ever been before?
That's exactly what it is we are proposing this as a long-term space travel waste management system because plastic is lightweight, it's cost-effective, it's not going anywhere, and we don't want a pollution problem like we've had on Earth.
Yeah, perfect. So I know that this is the first launch for both of you. Why don't we take a look around really quick? So there it is on the launch pad, Falcon 9 and Dragon. Inside Dragon is your experiment. How are you guys feeling?
It is surreal. It is, it feels like a dream, and it's about to be a dream come true, not just for myself and Claire, but for our whole team, for students at Stanford who also have an experiment going up, and for all the students who assisted us in our citizen science.
Perfect. Guys, I cannot wait to see what you discover. Thank you so much for your time, and I hope you enjoyed the launch.
Thank you so much.
And we have another student experiment on board Dragon today. These guys are in college, but we have a high schooler here. You see Celine Coquelar. She won the annual Genes in Space research competition by designing a new method of detecting water contaminants. If successful, her work could be used to test water quality both in space and also remote parts of the Earth. Genes in Space is made possible through Boeing, a startup called Mini PCR that makes equipment for biology research, and the ISS National Lab. All right, we're just under 6 minutes till, 6:56. I am having a hard time, guys, but we're close to terminal count. So let's bring back Shiva live from SpaceX headquarters in Hawthorne, California, and Daryl here on Florida Space Coast to walk us through the final moments of the countdown. Guys, take it away.
Thanks, Megan. Now, the SpaceX team is not working any significant issues with both Falcon or Dragon at the moment. And the weather, I hope, is continuing to trend well. Like Daryl had mentioned earlier, we're keeping an eye on some clouds and potential precipitation. And we're going to keep our ear out to the loops to make sure we remain go for launch. The range does remain go for launch at this time. Now, at this point, the Rocket Propellant 1 fuel is completely loaded on the second stage and nearly fully loaded on the first stage. Liquid oxygen loading is underway on both the stages. That'll complete at about T-minus 2 minutes to launch. At this point, we're also loading helium gas into both the stages. Falcon 9 uses that helium as a pressurant to backfill the propellant tanks as we consume that liquid oxygen and RP-1 by the Merlin engines during ascent. Helium load began before the broadcast went live, and it'll continue to top up until about a minute and a half before the launch.
To make sure engine startup goes well, SpaceX performs an engine chill. This happened, will happen, has happened at T-minus 7 minutes. Flowed a small amount of the super chilled LOX into the Merlin engine's turbo pumps. And this is done to avoid a thermal shock to the system when that flow of super chilled liquid oxygen hits the prop system. Now, Dragon began its startup sequence at T-minus 35 minutes when it coordinated timing with the Falcon 9. Dragon now currently undergoing vehicle health checks with the next big step just before liftoff when the cargo spacecraft transitions to internal battery power.
Dragon is in terminal count.
And we just heard that call out for Dragon being in terminal count. And the strong back retract, that's perfect timing. That large truss structure next to the vehicle is called the transporter erector or the strong back. And as was called out on the loops, it pulls away from the vehicle in preparation for liftoff. We'll see those clamp arms around the body of the second stage start to retract. And then shortly after that, the whole structure will pull away from Falcon 9. Now, in these last few minutes, Falcon 9 is performing a set of final health checks on its primary communications, avionics, and propulsion systems in preparation for liftoff just about 4 minutes away from now. We're also going to continue to hear call-outs throughout that the engines are sufficiently chilled in as we get closer to liftoff. And on our screen right there, you can see those clamp arms beginning to open around the second stage in between some of that cooling of the Florida air around the second stage. And shortly after, we'll see the white truss structure on the right-hand side of the vehicle begin to pull away from Falcon 9. There you can start to see motion of the transporter erector away. It'll recline a bit before we step further into the liftoff.
And coming up in just about a minute, Shiva, checkouts of the second stage thrust vector control actuators. They are underway. This is often referred to as the engine wiggle test. This is when SpaceX moves the thrust nozzle slightly to make sure that the guidance hardware is go for flight. Again, that was a great view of the transporter erector tilting back. SpaceX does the exact same checkouts of the first stage engines, and that happens just seconds before ignition. At the time of launch, 8:44 and 22 seconds p.m. Eastern Time, the International Space Station will be over the Pacific Ocean, 257 statute miles in altitude.
Now, we actually heard just about 30 seconds ago that liquid oxygen loading is complete on the first stage. And coming up here, just under 20 seconds, we'll hear a similar call out on the second stage. That will wrap up propellant loading on Falcon 9 in preparation for launch. At this point, Dragon is performing its final health checks to make sure we're ready to go for rendezvous with the space station about 38 hours from now. And I love the shot of the pad. You can see the clouds forming around Falcon 9 from that cooling. There's a call out there for LOX load complete. You can hear or see the water vapor condensing and forming
Dragon
clouds
is in auto idle
around Falcon 9.
Yeah, you sure can. And just a few minutes left in twilight. A little bit of illumination makes it nice. At T-minus 1 minute, Dragon will transition to internal power. Falcon 9 computers will enter startup mode and begin final pre-launch checks, guiding the rocket through the last seconds before liftoff.
Falcon 9 is in startup.
Here we have the call.
Dragon is in countdown.
Both stages are now pressurizing for launch.
LD is go for Falcon 9, CRS-25 launch.
So range is go, weather is go.
T-minus 30 seconds.
It's a beautiful time of day to watch this launch if you're out on the beach.
T-minus 15.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
Power and telemetry nominal.
We are 50 seconds into flight. Successful liftoff from the Kennedy Space Center, Launch Complex 39A. Falcon 9 is heading towards its next major milestone. For the point of highest stresses the vehicle will experience during ascent. There's the call out for maximum dynamic pressure. So from here, the stresses on the vehicle will get lower and lower as we raise our altitude. Coming up, we've got 5 events back to back. The first of those will be main engine cutoff, or MECO. That's where all 9 Merlin 1D engines on the first stage will shut down.
Back chill.
Following that will be stage separation, where the first and second stages will separate. The first stage will flip around to make sure it's headed back towards the landing site and our drone ship named a shortfall of gravitas. And then the second stage will ignite its Merlin vacuum engine to boost Dragon into low Earth orbit during second engine start number 1. We just heard the call out there for engine chill-in on the second stage engine starting. The last event is the boost back burn on the first stage. That's to reduce the velocity of that vehicle as we prepare for atmospheric entry. Now, all of those events happen over about 45 seconds. And again, they are main engine cutoff, followed by stage separation, first stage flip, second stage engine start, and then boost back burn start. All those happening in just about 5 seconds.
Miko. Stage separation confirmed.
Fantastic sight.
And back startup.
So the first 3 of those events are complete. And now the boost back burn is underway. The shot on our screen right now is of the Merlin vacuum engine on the second stage. And as this view toggles, you may catch the first stage. It is firing its Merlin 1D engines that burn on the first stage, lasting about 30 seconds. You can see the plume on the first stage on the left-hand side of your screen as we're doing the boost back burn.
Stage 1 boost back shutdown.
Successful shutdown of the first stage Merlin engines for the boost back burn. Second stage engine continuing to burn. That'll continue to burn until about the T plus 8 minute and a 40-second mark into the mission. Now, if you're just joining us, welcome to our 25th commercial resupply mission to the International Space Station for our customer NASA. You're watching our 30th mission of 2022 and the 3rd Dragon flight to the International Space Station this year. We lifted off just about 4 minutes ago from the Kennedy Space Center in Florida. On your screen are views of our first stage on the left-hand side of your screen with its grid fins deployed periodically, controlling its attitude to make its way back home. On the right-hand side of your screen is a shot of the Merlin vacuum engine on the second stage, performing its burn. It'll continue to burn for about another 4 minutes to take Dragon up to low Earth orbit. Now, speaking of the entry sequence on the first stage, to make its way back to that drone ship, it's going to have to execute 2 more burns. The first of those is the entry burn, where we'll ignite 3 of the Merlin engines, and that helps slow down the stage as we enter the upper part of the Earth's atmosphere. Following that, there will be a second burn, the landing burn, and there will only ignite a single Merlin 1D engine that'll bring the vehicle speed down to 0 for a soft touchdown on the drone ship. We've got some great sunlight on the vehicle, and you're periodically seeing some plumes of white. That's actually from our nitrogen gas thrusters that are helping to keep the first stage oriented, engines down, as we are in the vacuum of space at the moment. But once we get through that entry burn, the grid fins, which are deployed, you can see 2 of them on your screen, will then take over control as we start to get atmospheric authority. And then the first stage will only use those grid fins to steer back towards our drone ship. So entry burn expected to start about 10 seconds for now.
1 FTS is saved.
Just taking a quick look in, stage 2 engine performance, about nominal. Continuing to burn. We've got about 3 more minutes for that
Stage 1
burn.
entry burn startup.
You can see the velocity on the first stage, bottom left-hand side of your screen, rapidly slowing down as we
Stage 1
fire
entry burn shutdown.
the entry burn. That burn only lasting about 15 seconds. And now we're doing a quick attitude correction to make sure we're pointing the heat shield down. And that entry burn and the plume coming back on the stage ends up depositing a small layer of carbon on the vehicle, which is what gives our first stages that awesome sooty look once we've reflown them. Now, Falcon 9 also has 4 landing legs. They're made of carbon fiber and aluminum honeycomb. They're placed around the base of the rocket, and they'll deploy just prior to landing during the landing burn. If we're successful in recovering this Falcon 9, it'll mark its 5th successful landing and our 130th landing overall of a Falcon 9, including Falcon Heavy missions. The landing burn coming up shortly.
Stage 1 landing burn.
Keep an eye out on the speed on the left-hand side of your screen. That's the velocity of the first stage. We're going to see that come all the way down to 0. On the right-hand side of your screen is our drone ship. And also keep an eye out on the left-hand side of your screen for landing leg deploy.
Stage 1 landing leg deploy.
People real excited behind me. Right in the middle, 5th landing for this Falcon 9, 130th landing overall for an orbital class rocket. Beautiful sight to see. Now coming up next is second engine cutoff number 1, or SECO 1. We'll expect the Merlin vacuum engine to stop firing just about 30 seconds from now. It's carrying the Dragon spacecraft to its drop-off orbit around our planet. After we complete second engine cutoff number 1, we'll do a quick check to make sure that the burn performance is as expected.
Stage 2 FPS.
We're in the targeted orbit. We usually hear that called out as a nominal orbital insertion or a good orbit call out on the loops.
And back shutdown.
So you heard a call out on the loops there for shutdown of the Merlin vacuum. There's nominal orbital insertion. So that means that the ground teams have assessed the orbit and stage 2 is right where we want it to be. And of course, that also means that Dragon is right where we want it to be, since it's been riding on the the second stage this whole time. Now, if you're just joining us, we're about T+9 minutes, 20 seconds into the mission. On the screen next to me is a view of the Merlin vacuum engine with Earth behind it on the second stage. Now, the second stage has one major task remaining, that is commanding separation of the Dragon spacecraft just a few minutes from now. And we're hoping to have video of separation from the top of the second stage. We actually got a quick glimpse of it before, but we've got a camera that looks up into the trunk of Dragon and gives us a little peek at some of the cargo that we're taking in that unpressurized section. You can see the EMIT payload there on the left-hand side of the screen. Now, the CRS-25 capsule will be joining the Crew 4 vehicle, Capsule Freedom, which is currently on orbit. So we'll be back to dual Dragons docked at the International Space Station. CRS-25 will be headed to the Forward Harmony port on Node 2. We're expecting it to arrive on the 16th around 11:20 a.m. Eastern Time. There, it'll spend about 1 month attached at the International Space Station. Now, as for the cargo, today we are delivering more than 5,800 pounds of science, research, crew supplies, as well as vehicle hardware to the orbiting lab and its crew. And amazing, more views inside the trunk. Now, at this point, the second stage is performing its final checks to ensure that we're not imparting any unnecessary momentum or spin to the Dragon spacecraft. Once those calculations are complete, Dragon and the second stage will command separation. And shortly following separation, Dragon will conduct a series of health checks on its thrusters, its cabin, thermal, and solar systems, its navigation systems, in preparation for the upcoming 38-hour mission to the space station. Got about 30 seconds to go. If you're just joining us, we're looking at the second stage. Coming up real shortly to Dragon separation. This particular Dragon marking its third flight, and it also the first third reuse of our upgraded cargo vehicle. This view looking into the trunk of the Dragon capsule. That's our unpressurized portion of the vehicle. That's some of the payload that we're taking up to the International Space Station.
Dragon separation confirmed.
Phenomenal. So with that, CRS-25 gently floating away from Falcon 9's second stage. Again, coming up next, we've got some service section Draco checkouts, as well as nose cone opening. But that's actually going to complete my coverage here from Hawthorne. So I'm going to pass it over to Sandra at Houston to check in with the teams there. Sandra.
And thanks, Shiva. Welcome back into the International Space Station Flight Control Room. That was a beautiful launch from here in Mission Control Houston. Right now, we're just standing by for confirmation of the nose cone deployment. And we did just get confirmation that the nose cone was successfully deployed. That nose cone does cover the docking hardware, the navigation and rendezvous sensor, and the 4 forward bulkhead Dracos. The nose cone will stay open until the end of the mission, until after deorbit burn and just prior to re-entry. If you are just joining us, NASA and SpaceX's 25th commercial resupply mission launched from Pad 39A at the Kennedy Space Center in Florida at 7:44 p.m. Central, 8:44 p.m. Eastern Time this evening, and is currently in orbit and heading to the International Space Station. Dragon is filled with over 5,800 pounds of cargo and supplies, including a variety of science investigations, hardware, and fresh food for the crew on station, such as apples, oranges, cherry tomatoes, onions, carrot, garlic, tahini, and even shelf-stable cheese. On board the International Space Station right now is the 7-person Expedition 67 crew, who I'm sure is looking forward to these fresh foods. The crew includes NASA astronaut Bob Hines, European Space Agency astronaut Samantha Cristoforetti, Roscosmos cosmonauts Denis Matveev, Oleg Artemyev, and Sergei Korsakov, as well as NASA astronauts Jessica Watkins and Kjell Lindgren. And we're just continuing to stand by on that nose cone deployment checkout. Dragon is slated to dock to the International Space Station on Saturday at approximately 10:20 a.m. Central Time. NASA astronauts Bob Hines and Jessica Watkins will be monitoring the approach of Dragon. Earlier this week, NASA astronaut Bob Hines and Jessica Watkins spent some time reviewing procedures on a computer ahead of Dragon's automated rendezvous and docking. And the 2 flight engineers were also joined by NASA astronaut Kjell Lindgren, who helped stage cargo that will be returned inside Dragon at the end of its month-long mission at the orbital lab. And we are continuing to stand by for confirmation that the nose cone checkouts are complete. And we did hear that the first set of hooks is already driven, and the second set of hooks is currently driving for that nose cone deployment. All hooks are now open. Everything continuing to go smoothly. We should have confirmation here just shortly that the nose cone is successfully deployed. And we should have confirmation here shortly. And again, this nose cone does cover the docking hardware as well as the navigation and rendezvous sensors and the 4 forward bulkhead Dracos. And we're continuing to stand by for nose cone deployment. And we did just hear confirmation that nose cone deployment is complete. And with Dragon now safely on its way to the International Space Station and the nose cone successfully deployed, that will do it for us here in Mission Control Houston. Thanks so much for joining tonight, but I hope you'll tune in for the docking coverage on Saturday beginning at 9 a.m. Central, 10 a.m. Eastern Time. But for now, I'll send it back over to the Kennedy Space Center and Megan.
Sandra, thanks so much for walking us through that. That's going to wrap up our launch coverage of NASA's and SpaceX's 25th Commercial Resupply Services mission. As Sandra said, Dragon is on its way to dock to the International Space Station and is set to dock on Saturday at 11:20 a.m. Eastern Time. We will have live coverage of that beginning at 10 a.m. And if you're interested in tracking EMIT, again, one of those experiments on the mission that's studying the Earth's climate, you can do that by scanning this QR code you see on the bottom of your screen, or just write down the website here. It's earth.jpl.nasa.gov/EMIT. Once attached to the space station, EMIT will start collecting its first measurements by the end of this month. Again, thanks for joining us. We leave you with a replay of tonight's spectacular launch. Enjoy the rest of your evening.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.